8255, because in the last class we have studied about handshake. You must have seen those three blocks, and in between them there was a device which was PPI, programmable peripheral interface, which was providing ports to the peripherals. So now we'll study in the detail what was PPI, what it can do and how it works, what is the pin diagram, block diagram, modes of operation, interfacing principles, port mapping, port address designing. Fine, so there are lots of things which will be coming inside. Fine, so let's start with 8255. 8255 is a programmable device. What it has, the special part is the ports. It contains 3 ports and all of them are of 8 bits. So it means it has dedicated 24 pins which will be acting like input output only. Only input output pins. That's why they are called the ports, because ports are dedicated for input output only. They are the dedicated lines for input output only. This is how we define a port. Okay, since this is a 40 pin IC, so out of 40, now you can see 24 pins are only for input output. Almost 60% is employed only for input output. Rest we have data bus and some essential elements. So this will be the most easiest time pin diagram you will study, and I'll tell you how to draw that also. And in the compatibility, it is TTL compatible. TTL means transistor logic. It is a logic family, so it holds a compatibility towards TTL. You can leave the improved DC driving capability. It's not for you. So this is the 8255 interfacing card. This is how it looks like. Fine, there is an IC in between. That is your 8255, and it's connected with many things like LEDs, these switches, black switches again, then headers, 2 type of headers, 50 pin header and then 20 pin header. Fine, so now you can see this is the perfect IC which actually transfer the signal from one to another, from processor to peripheral or peripheral to processor. Okay, so this is how the pin diagram of your 8255 looks like. Fine, so let's study that pin diagram. Are you guys able to see this?
Yes, sir.
Okay, so this is the pin diagram. Yeah, hello? Any problem? Okay. So what we have here is the pin diagram. You can see the same pin diagram I'm having here. All right. So you can see the number of pins, how many pins we are having. We are again having the 40 pin. The package is called DIP, dual inline package. Okay. So this particular pin diagram, if you want to draw, let me tell you the tricks, because there are so many pin diagrams you need to remember. All right. So in this, look, I've used colors also in order to identify different sections of this. So what we are studying in 8255 is it contains 3 ports: port A, port B, and port C. Port C is further divided in 2 parts: port C lower and port C upper. Okay, so how do we identify the number of pins? The way to write is this: PA0 to PA7. Fine. These are 8 bits. PA, port A, and this is the bit number. Same for port B, PB0 to PB7. A little different for port C, since it is lower, that means lower 4 bits. PC0 to PC3. Upper one, PC4 to PC7. Fine. Same thing you will see in the pin diagram: PA, PB, PC, PC. So wherever you are finding A along with the P, it is port A. B, port C is ports. Okay. So now look into the pin diagram. what we see on the top where pins are marked by red, starting from pin number 4, start from pin number 4, PA0, PA1, PA2, PA3, and now go clockwise 4, 5, 6, 7. Fine. So that section of your pin diagram is your port A. That section of pin diagram is called port A. Fine. Is that clear? Now come to the bottom again, the green one. Directly fall into the bottom. That section is your B. There is just one difference. At left side it will be having only 3 pins, 0, 1, 2, and it will go anti-clockwise. Okay, 0, 1, 2, 3, 4, 5, 6, 7. 3 this side, 5 pins this side. A opposite B, and next to B is the blue one. This is your C, which is port C, and in front of C, this is your D. Now what is D? D stands for data bus. D stands for data bus. Fine. Okay, so is this pictorial representation better? You can see in the form this whole pin diagram in the form of blocks. All right. Is it getting better?
Yes, sir.
By colors, at least now you can visualize by remembering अच्छा top पे A था, bottom पे B था, side में C था, C के सामने D था. At least now you can actually draw the 60% pins. Fine. And there are few trick points you need to remember that I'll tell you how to remember that. So let's take the pin diagram in detail. So what we have here, pin port A, PA0 to PA7, that belongs to port A. We have seen in the top part, which is your 8 pins. PB0 is port B, again 8 pins in the bottom. Port C on the left side, but this is not what it looks like. Here you are having a little flip-flop. What is the flip-flop you are having here? PB0, now look into the top. It is divided in 2 parts, but in a flip-flop manner. Bottom 0, 1, 2, 3, but top 4, 5, 6, 7. 4, 5, 6, 7. So this is the way they have arranged the PC upper part and PC lower part. This is just one thing you need to remember. Fine. So we can write here PC lower or PC upper. After that, there are few pins we are having, like this pin number 5, which is RD bar. RD stands for read. Fine. Read, and other one was write. What these two are? These two are control signals. Fine. And they will be driven by the microprocessor. When processor wants to read something, it will send the command read, it will send the command write when it wants to write simultaneously. So they are the control signals. They will be governed by the actions from the microprocessor. Okay, so next we have pin number 5 and pin number 36. Now see what happens here. After port A, pin number 5 is read. Read का opposite में क्या है? Write. Look into the opposite. Read, write. Read, write. Is that clear? Next we have CS bar. Pin number 6, CS bar stands for chip select. You might have seen already there are few signals in digital electronics. They are like enable, active. Fine. It is the same. It is just a selection signal. What it needs, since it is having a bar, that means it is an active low signal. So if you want to select 8255, what you need to provide is an active low pulse to CS bar. That means a 0 is required if you want to select this particular IC at pin number 6. At pin number 6. If it is not, it will be disconnected from the circuit. Fine. So chip select at pin number 6. Opposite to chip select is reset. Opposite to chip select is reset. Select, reset, select, reset. Just try to learn in remember in a rhyming way. Select, read, write, select, reset, select, reset, select, reset. So what reset will do? It will reset the pointers inside the 8255. The data pointer, address pointer, stack pointer, there are many pointers which are running the moment we are executing a program. So it is about resetting and sending the signal back to pointers so that it can fall to their ground state. Okay, so this is your reset part. Now after reset, at pin number 7, we have ground. Okay, so there are two very important things in the circuit. One is called VCC, which is your power supply, which is your plus 5 volt, and other terminal is called ground, which completes the circuit. Fine. So VCC and ground, they both are connected together. That means they work in synchronization, or they work in sequence. Fine. They work together basically. So now look at the pin number of ground. What is the pin number of ground? That is 7. Fine. And what is the pin number of VCC? 26. 2 plus 6, 8. And what is the pin number of ground? That is 7. 7 के बाद क्या आएगा? That will be 8. So this is the only pin that you need to take care, which will be creating a differentiation or a barrier between the data bus and the port B, upper part of port B. Only this thing. Where this VCC will go? 7, 7, 8, 2 plus 6, 8, VCC. Alright. Are we getting it? How to remember this whole thing?
Yes, sir.
Yes, next is your A1 and A0 that you're watching in pin number 8 and pin number 9. A1 and A0, they are called selection lines. A1 and A0, they are called selection lines. So sometimes we also call them select lines. Fine, they work in close coordination with CS bar. Fine, so what selection we need to do? What selection are we actually looking for? Fine, so selection by selection, let me write the table. So what do we want to select here? The selection is, there are many things inside port A, port B, port C. So how we are going to select port A, port B, port C? Is there any way? Are we provided with any kind of switch? No, we are not provided with anything. This is the decoding table by which your port A, port B and port C will be selected. By the selection, what does it mean? It means I say transfer this content out from port A. Okay. So that is my concern, that port A should be considered. So that moment A1 and A0 should be 0. Fine, so this is my concern, what port I'm going to select. Okay, now how CS bar is very important with this, because if you want to operate with 8255, CS bar must be provided with 0 all the time. So that's why it has to be taken in this table. If CS bar is 1, there is no A1, no A0, the action is simply 8255 not selected. Fine, and we are missing one thing also here. 011, at 011 the selection is CR. Now what is CR? CR is again a very important part of all the interfacing ICs. CR stands for control oblique command register. It can also be called control register, or it can also be called command register. Okay, this is the definition or explanation of CR. Now what this control register is? See what happens in the interfacing ICs. They do not have a logical component inside so that they can think. Fine, we have a brain so that we can think logically and illogically as well. But in the interfacing ICs, they are not designed to think in such a way that a master microprocessor can actually do. I'll show you the block diagram, then you will see by yourself. There will be no ALU, there will not be any flags, there will not be any logical circuitry to understand something, to compare something, to tell us something. This is the decision to make. You will not find these kind of circuitries which are actually needed to make a decision. Okay, what interfacing ICs are designed, how they are designed only to receive the command, store it inside, get a little modified according to them, then it can be executed. They are not totally designed in such a way so that they can be programmed by itself. No, a program has to be loaded inside them. A program has to be loaded inside them. But when the program will be loading, where the program will be loading, what is the space? Because it is the form of binary. Binary is needs to be stored somewhere. Fine. So what this control register is, this is the space. This is an 8-bit register. What it can do, it can store the command of the microprocessor inside in the form of binary. So control register is nothing, it's just a space inside the interfacing IC which receives the command directly from the microprocessor. Fine, so if you want to select the CR to load the code coming from the microprocessor inside the CR, you need to select CR also. So for selection 011 is the pattern so that your CR can be connected to the microprocessor. Is that clear? Is that clear? Control register?
Yes, sir.
Okay, and is there anything left in the pin diagram? I hope not. No, it's clear. Are we able to draw? Now can you draw the pin diagram? एक दो बार draw करोगे, trust me, you will not be able to. You will not forget it for a lifetime. You just need to practice in a way 2-3 times, like I've just shown in the segmentation of image. Okay, and you will never forget this thing. So this is the block diagram we are having right now on the screen. Fine. So are you guys able to see that?
Yes, sir.
And this is the beginning. After this, you will have 8254, 8279, 8259, 8051. There are so many ICs lined up, and every IC will have same pin diagram, block diagram. You have no idea कब किसका कौन सा एग्जाम में आ जाए. So there are few tips and tricks you need to develop always. Today I'm just giving you a demo how you can develop the tips and tricks so that you can remember for a long time and a better way. Okay, one thing we have seen in the pin diagram. So do you want me to tell you the tricks to remember these block diagrams as well?
Yes, sir.
Because the diagram that you are watching on the screen right now, trust me, you can draw this thing in the 15 seconds. It will take only 15 seconds to you to draw this once you understand the concept here, because everything is governed by the concept. Fine. Once you understand the concept, it is very easy again. Okay, let me take you back to. Okay, then. So let's talk about the block diagram here. But before starting with the block diagram, we need to understand the concepts behind designing the block diagram of 8255. So what are the concepts we need to understand? See, 8255 works in the form of groups. There are two groups in 8255. The designers have done the whole design in such a way. There are two groups. I'm not writing the name, I'm just leaving it right now, but just look at like a group and what it constitutes. Fine. So in groups there are two things. One thing is called, since it is port IC only, so we'll be having only two things, which is called major port and other thing is called minor port. Same phenomena is for other group as well. Major port and minor. So what major port we are having in the group A? Fine. So now look, group A. I'm writing A in the group name. What will be the major port? Same, port A. What will be the minor port? Port C, upper part. Okay. Next is group B. Major port B. Minor port C, lower. Fine. So this is what we have to understand. What I was trying to say, it works in the form of groups. So this is your first group and this is your second group, titled as group B and group A. Group A contains major port, which is the name of the group A, minor port PC upper, group B, name of the port major port B, minor port PC lower. This is just you need to understand before drawing the block diagram of 8255. Okay, so let's draw. So how many elements we have discussed? We have just discussed there are two groups and every group contains two elements. So in total what we are having is four elements. Fine. So just take a shape. We can take a rectangular shape. Fine, like I'm taking. Just draw four similar shapes on the right side of the notebook or your page, because there are four elements, two elements in each group and there are two groups. Okay, so what these elements are, the same elements we were having in the group. Fine. So let's say this is group A. So what is the major port in group A? Port A. Minor port in group A is port C, upper. Okay, so what we are left with, group B. What is the minor port in group B? Port C, lower. Major port in group B? Port B. There's a change of color here. Okay, that can work. Port B. Since they are ports, what they are destined to? They are destined to provide the bi-directional in-out. Bi-directional in-out in both the directions. Ports are designed to provide the bi-directional data in both directions. So this is the direction of data from ports. Okay, so where these ports will be connected, we again need a shape to connect. So they will be connected to the data bus. So this is the bus we are having. Okay, they created a block. Okay, no problem. Let's create it again. Okay then, so just a little modification. Just imagine these are connected like this. All right. So what we have just drawn is the basic structure. Okay. So in order to control these two groups, we again need two groups controller. So on the left side, just draw two more blocks, and these blocks will be simply written as their group controllers, like group A control, and the bottom one can be written like group B control. All right. So they will be simply connected to what they are going to control. So if I talk about group A, what group A is going to control, it will be simply controlling what they are needed to. They will not be controlling anything else. Group A will not be controlling group B. Same thing with group B. Group B will only be controlling, or it will be only connected to those which are actually the part of group B. All right, is that clear? Okay, then so now we need one more thing. Something which controls everything overall. And what do we call that? We call that control unit. We call that control unit. Now, in the interfacing ICs, the control units are not plain control units, they are more than that. Like in 8255, it is called read write control logic. It is read write control logic. Fine. And what they are connected with? They are connected with read write signals, A1, A0 selection lines, chip select, and reset also. So all those functional pins will be part of the control logic. Fine. Now control logic, or the simply you can also call it like a small control unit. It is the job of this that it will be controlling everything. It will be connected to all each and every block. Fine. Just remember one thing. Whenever we are having interfacing, there will be a data bus buffer with every interfacing IC as a common block. As the common block. So just keep a common block named as data bus buffer, because that will be storing all the data and it will be remaining in close coordination with the data bus. It will remain close to the data bus. So this particular block will be common in all the interfacing ICs, which is called data bus buffer, and it will be connected to D0 to D7 both sides like this. Fine. Now see what's going to happen next. The control unit, the control, it will be connected to every block. Fine. See, data bus buffer, group A control, group B control, and then to all the ports. To all the ports. Fine. Can you see now that control logic is connected to all the particular units, every block in this diagram? Can you see that?
Yes, sir.
Okay, and group A is connected with group A only, and group B is connected with the group A, group B only. And there is one data bus buffer which is connected to the data bus closest bidirectional both sides. Fine. Now let's add some chitter chatter to this recipe. Group A port A, how port A is written? PA0 to PA7. Port C upper, PC4 to PC7. Port C lower, PC0 to PC3. Port B, PB0 to PB7. Fine. Is that okay? Are you getting any difficulty in drawing this? So this is the connection point we missed. That group A will also be governed by a data bus coming from this data bus. I hope this is perfect now. Right here VCC plus 5 volt and ground. The rest is fine. The rest is almost fine. Yes.